Hi, my name is Patakit and I'll be talking about Lab 4, oscillations. So, what's the purpose of the lab? The purpose of the lab is to examine the motion of a spring mass system in which the mass swings in an arc while also oscillating on the spring. And the question for this lab is, does the model follow the energy principle? And the result that we get is yes, it does. But first, let's talk about some physics principles. Newton's second law. We learned from the last 3 labs that the rate of change in momentum is equal to the vectorial sum of forces on the body. Additionally, we can derive the velocity and position update formula from Newton's second law. Another physics principle we need to know is the energy principle, which says that the change in energy of a system is equal to the work done on the system, plus the change in thermal energy. By choosing the object, Earth, and everything as a system, the total change of energy can be 0. And we get that the sum of all the work done on the system is equal to 0. The last physics principle and formulas are the kinetic energy, gravitational potential energy, and spring potential energy, given by the formulas K equals mv squared over 2, Ug equals mgh, and Us equals ks squared over 2. Now let's look at our code. The ball's mass is given in the video. The ball's initial position can be examined by looking at the video, and its velocity can be approximated to match the video as much as possible. Additionally, we can derive the gravitational spring constant, the relaxed length of the spring, as given in the video, though these could be solved for by finding the oscillations period to solve for the spring constant, then calculating the relaxed length through considering the net force and its components, and finally we calculate the system's energy by using the various formulas we learned before. Next is the iteration step. First, we calculate the gravitational force and the spring force on the ball. Now that we have the net force by summing the two forces, we can then use the velocity and position update formula to update our ball state. Then, with this updated state, we can calculate the change in energies in the same way we did for the previous step. Now, let's look at the results. Some possible sources of errors is the difference in starting conditions between the simulation and the experiment. There can also be loss of energy to the surroundings since it's a real system. And finally, there could be inaccurate tracking which can lead to errors. So, what does this all mean? Is the energy principle still satisfied? The answer is yes. The energy principle is satisfied. Even with loss of energy in the real system, the surroundings, the change in total energy, remains 0 throughout the whole simulation. Now, we can also calculate the period of oscillation using the data from the x and y positions. And this can be done by finding the differences between the apexes of the oscillation graphs. The periods of oscillation are very similar, though they are not identical, and one factor that affects this is the initial conditions of pushing the mass. Thanks so much for listening.